Hello students, welcome to Akshara IT Foundation. So myself I am Shivashankar, I am your physics teacher. Today we are going to start a motion of force, center of mass. Exercise problems will start there, okay? Motion of center of mass. Exercise 1. Exercise 1. First problem. Exercise first problem. See here it is given that 2 kg body and 3 kg body are moving along x-axis with velocities 3 meter per second and minus 1 meter per second respectively. The moment of center of mass is given here. So here a body is there. This is a 2 kg body and 3 kg body. 2 kg body and this is a 3 kg body, and 2 kg body is moving with a speed along x-axis with velocity. This is moving with velocity u. V1 is equals to 3 meter per second, and this body is moving with a velocity minus. So V2 we can write here minus 1 meter per second there. So now they are asking the velocity of the center of mass, momentum of center of mass, So we know that according to the momentum of center of mass, is equals to, here we can write there. So P1 plus P2, we can write now. Then here moment of center of mass PCM can be written as here. This is nothing but here M1 V1 plus M2 V2 we can write. So what is the M1 here? M1 is 2 kg and V1 is 3. So 3 meter per second plus M2 is here 3 and here velocity V2 is minus 1. So here we will get there 6 minus 3 will get. So here 3 kg meter per second. So this is a momentum of center of mass, linear momentum of center of mass. That is the answer. Okay. Completed now. Second one. Two bodies of masses 6 kg and 4 kg are moving along eastern and northern directions with velocities 5 meter per second and 10 meter per second respectively. Find the magnitude of velocity of center of mass. Velocity of center of mass. So here second one it is given there like this. So two bodies of mass is 6 kg and 4 kg. So they are moving. 6 kg mass is moving here. Let us consider that is M1. It is a 6 kg mass moving with velocity V1. Eastern direction. It is given there 5 meter per second. This is a 5 meter per second. And northern direction M2 mass is 4 kg. So M2 mass of the body is 4 kg. It is moving with the speed. It is a V2. It is moving along the north direction there. Then velocity of the center of mass we should find out there. Velocity of the center of mass. So velocity of center of mass we can write like this, no? So here mass of the center of mass and velocity of the center of mass is equals to, so M1 V1 center of mass is equals to M1 V1 plus M2 V2 we can write now. M2 V2 we can write that. M2 V2. This is a resultant of center of mass. So here this M2 and V2, this is moving. So here we can write the momentum is here along x-axis is P1, along y-axis towards north it is P2 we can write there. Now the resultant of this center of mass momentum is like this. That is a resultant momentum. So that can be written here. So P suffix R. PR can be written as here. This is a square root of P1 square plus P2 square, P1 square plus P2 square, because here the angle between the two moments is 90 degrees, no, it is 90 degrees. Resultant momentum will be like this. So that is the MCM, momentum, center of momentum is, that one will get here. So PR is equals to square root of P1 square. P1 square is nothing but what can we write here? So M1 V1 square plus M2 V2 square. M2 V2 square we can write here. So therefore here we can write there 6 into 5, we get there 30, 30 whole square. This is a 30 whole square plus 30 whole square, 30 plus M2 V2, 4 into this V2. This is given here 10, no? 10 meter per second. So we'll get here, this is a 40, 40 whole square will get. So the value will become here how much? This is a 900, 30 square is 900, 40 square is nothing but 1600 will get there. So that is equals to 2500, 2500. So this is equals to, here we'll write there 50 kg meter per second. 50 kg meter per second. This is the resultant momentum, that is equals to, here this value will be equal to what there? Moment, center of mass, mass of the center of mass and velocity of the center of mass. So from here we can write there VCM is equals to 50 divided by mass, that is capital M. Capital M is nothing but M1 plus M2, no? So 50 divided by M1 plus M2, M1 plus M2. So 50 divided by M1, how much there? 6 and M2 is 4 there. We'll get there 10. So this time this will be cancelled. Therefore VCM is equals to, we'll get there 5 meter per second. 5 meter per second. That is the answer. Completed now? Next one, we will see that here. Consider a system of two identical particles. One of the particle is at rest and other has an acceleration a bar. The center of mass has an acceleration of. Consider a system of two identical particles. One of the particle is at rest and other is moving. Is an acceleration a bar. The center of mass of the acceleration. Center of mass of the acceleration here. See a third one. So two particles are identical. Identical means they are the same masses. So here we can write that M1 is M and M2 is also M there. This is at rest there. So A1 we can consider here 0 and A2 we can write here, this is a bar. A bar. So now the moment of center of mass ACM can be written as M1 A1 plus M2 A2, no, M2 A2 divided by M1 plus M2. This is the formula of the momentum of the center, acceleration. Acceleration, center of mass of the acceleration. So that is ACM is equal to M1 A1 plus M2 A2 divided by M1 plus M2. So now here mass is here M and A1 is 0 plus this one is mass is M. And from here it is at A bar we can write divided by, so M1 plus M2. So it is M plus M. So what will get there here? M into A bar divided by, here will get there 2M. So M and M will be gets cancelled. Then ACM is equals to A bar by 2 will get there. A bar by 2. So that is the answer. Third one. A bar by 2. So next problem, fourth one. Fourth one. A pulley fixed to the ceiling carries a string with blocks of mass small m and 3 small m. The masses of pulley and string are negligible. What is the acceleration of the center of mass? What is the acceleration of the center of mass? See here, it is connected like this. So over a pulley, there are a string is taken, and to the ends of that string there is a m mass. Let us consider this is a 3m mass, and here m mass are tied at the ends of the string, and that is placed over the pulley there. So now here they are asking the what is the acceleration of the center of mass? What is the acceleration of the center of mass? They are asking there. So generally, see here this particle, if it is moving downward with acceleration a, so this will be moved with acceleration upwards a. Okay. So masses here, accelerations are there. First we should find out the acceleration. So acceleration, how can you find out? By using this formula, no? So m2 minus m1 divided by m1 plus m2. So it is also this string and pulley system, the Atwood machine, the acceleration of the Atwood machine we can find out by using this formula. So here we can write now m2 is nothing but 3m, we can write minus m divided by, so 3m plus m, we will get here 4m, no? 4m into g. Into g will get, so a is equal to how much you get here now here? So a is equals to, so minus 2m by 4m into g. So we will get here mm will be cancelled and 2 1s are 2 2s are. So g by 2 will get there, g by 2. So now here we can write this is a g by 2, it is moving downwards, and this is, it is moving upwards. We can write here minus g by 2, we can write now minus g by 2. Now the center of mass of acceleration, let us consider this is a a1 and this is a a2 there. So mass is here m and a1 is this one. So now the center of mass of the acceleration formula can be written as here m1 a1 plus m2 a2 divided by m1 plus m2 there here. So m1 is what here? M, and a is minus g by 2, okay, plus m2 is here m, and a2 is a by 2, sorry, g by 2 divided by m1 plus m2. So m1 plus m2, it will become 4m, no? 3m plus m, 4m will become. Okay, now, so here ACM is equals to, what will get here? Minus mg by 2, plus here minus mg by 2 plus mg by 2, no? Plus mg by 2. So here we can see here, this is moving upwards, it is moving upwards and it is moving downwards there. So here we will be consider the origin, like suppose if we consider here the origin there, mean position. So it can be taken as positive along the positive y-axis, and this is a positive or negative x-axis we can write now here. So xcm is equals to minus mg by 4, no? This is acceleration and it is moving with this mass m1 minus m2 we can write there. So you take the here acceleration in the Atwood machine, this is a plus only we can take here. So plus you take here, so we will get how much then? Plus mg by 2 plus mg by 2 will get divided by, sorry, this is minus only, here you write there minus mg by 2. Okay, so now here we'll get there the second mass, m2 is what there? M2 is 3m, no? This will be the 3m mass. So it is 3 mg by 2 will get 3 mg by 2 whole divided by 4m, So how much will get here? Now the center of mass is equals to, so it will be, so 2 mg by 2 will get there. So here mg will get, no? 3 mg minus mg, so 2 mg divided by 2 there, 2 will be cancelled there, mg will be remain, and divided by here 4m is there, okay, 4m will be there, and this will be cancelled there, therefore we will get there ACM is equals to, so g by 4, ACM is equal to g by 4. So here this has to be taken positive and this has to be taken negative. So now here if that is the negative there, no, so this will become positive, and here this will take the negative there. If you take this is a negative there, it is a 3 into m will get. So now here it is a plus and this will be a minus. So we'll get here this is a minus. So here we'll get there minus. So minus g by 4, minus g by 4 will get there. So this is moving negative y-axis and this is moving positive y-axis there. So based on the coordinate system we can take that. Completed now? So next one, fifth one. Two bodies of 6 kg and 4 kg masses have their velocity 5 I cap minus 2 j cap plus 10 k cap and 10 I cap minus 2 j cap plus k cap 5 k cap respectively. Then the velocity of their center of mass. Velocity of the center of mass we should find out there. So the velocities are given in the form of vector. Okay. So now right here, fifth one. So m1 is equals to 6 kg and here v1 is equals to m1 is 6 kg and v1 is equals to 5 I cap minus 2 j cap plus 10 k cap plus 10 k cap plus 10 k cap and m2 is equals to 4 kg, m2 is equals to 4 kg and v2 is equals to how much? v2 is equals to, it is given there. So this these values are not printed in the question in the textbook. You can so write these values there. Okay, write the vector, velocity vector there. v1 and v2 vectors you should write there. So 10 I cap minus 2 j cap plus 5 k cap plus 5 k cap respectively. Then velocity of center of mass. So velocity of the center of mass they are asking there. So velocity of center of mass formula we know, no, that is m1 v1 plus m2 v1 bar m2 into v2 bar divided by m1 plus m2, m1 plus m2 there. So we'll get a this velocity vector will get there, center of velocity of the center of mass vector will get here. So this is 6 into v1 is how much there, 5 I cap minus 2 j cap plus 10 k cap and plus 4 into 10 I cap minus 2 j cap plus 5 k cap plus 5 k cap plus 5 k cap whole divided by here m1 plus m2. m1 plus m2 is how much there, 10. 10 will get there. So now here the multiply there. So 30 I cap minus 12 j cap plus 60 k cap plus 60 k cap plus 40 I cap and here minus 8 j cap and plus 20 k cap plus 20 k cap divided by 10 divided by 10 divided by 10 there divided by 10. Now, so here you see the 30 I cap 40, this is a 40 I cap there. So we'll get there 70 I cap, no, 70 I cap and minus 12 j cap minus 8 j cap. So we'll get here minus 20 j cap minus 20 j cap 60 plus 20 k cap there. Okay. So it is 80 k cap will get, no, divided by 10 divided by 10. If it is divided by 10 we'll get here 7 I cap minus 2 j cap plus 8 k cap. It is the velocity of the center of mass vector. This is the answer, velocity of the center of mass of the vector there. 7 I cap plus 7 I cap minus 2 j cap plus option 3 is correct. So sixth one, a bomb is initially at rest on the ground and suddenly explodes into the two fragments of equal masses. One of the fragment is found moving north with velocity 20 meter per second. Velocity and acceleration of the center of mass of the bomb after the explosion. Okay. So here one bomb is moving towards. If a bomb is exploded, initially that bomb is at rest on the ground, suddenly explodes into two equal masses. One fragment is found moving north with velocity 10 meter per second and velocity and acceleration of the center of mass. If the internal forces, bomb will be exploded due to the internal forces, no? The internal forces cannot be changed the center of mass of the velocity of the center of mass and acceleration. Center of mass, position of the center of mass cannot be changes. So here now we can write here velocity and center of mass. Acceleration of the center of mass will be 0. So we can say directly sixth one due to the internal forces does not change the center of mass. So velocity and acceleration of center of mass is 0. Therefore, V is equal to 0 and A is equal to 0. That is the answer. Okay, now seventh one is there here. Two blocks of masses 2 kg and 1 kg respectively are tied to the ends of a string which passes over a light frictionless pulley. The masses are held at rest at the same horizontal level and then released. The distance traversed by the center of mass in 2 seconds is. Okay. So here the diagram is given like this. There is a pulley is there. Over the pulley by the string there is a mass of 2 kg is placed here and another one is mass of 1 kg. Another one is mass of 1 kg is placed here. This is a mass of 1 kg. It is the mass of 1 kg. Okay. So now in 2 seconds, initially they are at rest there. So when they are here kept there, initially they will be at rest there, and here the tension will be there. Here the tension due to the weight of these blocks, there is a tension will be present in the string. So that is T here. Okay. So now it will be moved with certain acceleration. No? So acceleration of this block, how to find out the same formula? That is here A is equals to m2 minus m1 divided by m1 plus m2 into g. So here they said here this is a 2 kg minus 1 kg divided by 2 plus 1. 3 will get here, 3 into here 10 will get. Okay. This is a 10. So we'll get how much there? 1 by. So 10 by 3. 10 by 3 meter per second square will get there. So initially they are at rest means initial velocity will be 0 here. U is 0. And it is moving with this and time is given there with it is moving with the acceleration 10 by 3 meter per second square, and in 2 seconds they are asking, no, in 2 seconds. In 2 seconds what is the distance traveled by the blocks? Okay. So then here we'll use here S is equal to ut plus half at square formula of at square formula. Okay. So now here S is equal to this u is 0 means this will become 0 plus half into A value how much we got there? 10 by 3 T is how much here? 2 square means 4 will come here. 2 square means 4. So 2 1 the 2 2s are. So we'll get there 20 divided by 3. So we'll get how much then? 6.66 meters. 6.66 meters. So here this block is moving downwards and this will be move upward. No? So the distance is S will be there. This block will be moved downwards, and at the same time the block M1 block will be moved upwards. M1 block will be moved upwards, and M2 means 2 kg block will be moved downwards there. The distance traveled by the blocks they have said, no? The distance traveled by the block. Center of mass. Distance traveled by the center of mass. Distance traveled by the center of mass. So this will move S distance and it will come downwards. S distance. So we'll get here, this is a 2S will get, no? This will be the 2S will get here. S is equal to 6.66 divided by 2, we can write that is equal to 3.33 meters. Therefore, S is equal to 3.33 meters. Eighth one there, next. A block of work mass, capital is top of a bigger block of mass 10 capital M, as shown in the figure. All the surfaces are frictionless. The system is released from rest. Find the distance moved by the bigger block at the instant of smaller block reaches the ground. Okay. So here the diagram is given like this in the 8th problem. This is the capital M mass, and this bigger mass is the 10 times of the smaller block, and there is an angle here theta, and this it is given there 2.2 meters is given here. So here they are asking the center of mass. While it is moving here certain distance, then this block will become downwards. The block will become downward. While it is reaching the bottom, then how much distance it can be? The bigger block can be moved. Okay, so then moment of center of mass. The moment of center of mass will be here same. No, we can write there. Suppose if it is moved here x distance, and this block will be moved here same x distance downwards. So here we can write there x. The distance moved by this one is 2.2 plus x, we can write, no, is equals to 10 m into x. Center of mass will be same. Center of mass does not change. Okay. So now here along the horizontal direction, there is no forces acting now. So then it will be like this. Then here 2.2 capital M plus here we can write this one m into x. If this is moved downwards and this will becomes x axis, x distance left side. So we can write here. So minus we can write 2.2 minus x. So here we will get minus capital M into x is equals to 10 into capital M into x. So now from this 2.2 capital M is equals to, if you send that side, it will become there 10 plus 10 mx plus mx. So we'll get here 11 mx. No? So 11 mx will get. So now x and x will be cancelled there. Then x is equals to, here we'll get x is equals to 2.2 divided by 11 will get, this is equal to 0.2 meters. So therefore x is equal to, it will move there 0.2 meters. The bigger block will be moved a distance of x meters towards right. So ninth one is also directly, because we know that the center of mass, no, the center of mass about the reference axis. The center of mass about the reference axis 0. Total momentum of the system from the frame of reference attached to the center of mass. So total momentum about the center of mass is 0. So we'll get here directly, we can say the answer is 3, option 3. The ninth one is direct answer. Option 3. Option 3 is right. Since momentum is 0 about the center of mass, P is 0, linear momentum will be 0 about the center of mass. Now 10th one is given here, 2 blocks. So 2 blocks of mass here M, another block here mass, and here there is a constant force is applied here, there. Okay. So then this is a mass M and this is a mass M. If the force is applied here, this whole system will be moved with acceleration A. So from that we can write here F by M plus M, 2M we can write now, acceleration will be the 2M there. This is a mass M there. Okay. So now here they are asking the 2 blocks of equal mass M are connected by unstretched spring. It is not stretched there, okay. Then the system is kept at rest on frictionless horizontal surface, constant force is applied. If it is not unstretched, then it is not unstretched. So it will be the constant. Then it is like a string we can consider, no? String we can consider. These are 2 masses and the center of mass will be exactly at this position, at the mid position. Then velocity of the center of mass we can write here 0 meter per second. Okay. And if you apply the force here, this will be moved from here to here, somewhere some certain distance, x distance it can be moved from here. Okay, it can be moved from here, this one, s distance it will move there. Then in time t they are asking, so we can write this s is equal to ut plus half at square formula, s is equal to ut plus half at square. Then from this s is equal to u is 0 here, then t is how much there, t seconds, plus half into a value, how much you got there, f divided by 2m is there, no, f divided by 2m into t square. So therefore from this what can you write there, this will become 0 into t, it will be 0 there, plus half into, okay, here f divided by, this is a 2, no, it is 2 here, 2 into 2 it will become 4, f divided by 4m t square. So therefore the answer is here f t square by 4m, f t square by 4m is the answer. Okay. Next 11th one. A body of mass m. See here 11th one, it is like this. A body of a smaller mass is dropped from this certain height there. So this is a height, from certain height it has dropped. The smaller block of mass is, smaller mass of block, it is dropped there. And another mass of block, it is capital M, it is thrown with velocity u vertically upwards. Whenever this is reached to the minimum there, maximum height, whenever it is reaches to the maximum height, means the final velocity will become 0, no, this one, okay, maximum height, then the final velocity of that block will be 0, the initial velocity will be here, this one is there. Then whenever it is dropped, u is 0, this, whenever it is dropped there, initial velocity will be 0. Okay. So here they have said there, the question is, if the body reaches the highest point before before the dropped body reaches the ground there. Before the dropped body is reached the ground, this m will be moved to the maximum height there. Okay. So then the maximum height raised by the center of mass. Maximum height raised by the center of mass there. So this is the h will be the maximum distance between the maximum height of the tower, we can say. Okay. So now here what can we write this one, the momentum. If you apply the momentum here, so this block, velocity of the center of mass, what can we write here, m1 v1, m1 v1 plus m2 v2, m2 v2 divided by m1 plus m2, m1 plus m2 we can write here. So smaller, this is it is dropped there, So if it is dropped means this velocity will become 0 there, m into 0 plus here m2 is the capital M2 is capital M, and it is thrown with velocity u. It is thrown with velocity u divided by, so small m plus capital M. Small m plus capital M. This is the velocity of the center of mass. Initial velocity of the center of mass, otherwise you can consider there u. So it is a capital M into u. U dash you consider there, no problem. Here m plus capital M plus capital M. So now the center of mass, this one, if it is thrown upward now, this one, and it is come downward there, the center of mass will be this plus the maximum height reached by the body, second body. Maximum height reached by the second body. So here we can write H maximum. H maximum formula is what there, whenever it is thrown vertically upwards. This is a formula, no? U dash, here U dash, no, that is U dash square divided by 2 into G there. So here what will get there, 1 by 2 into U dash square, what we got there, that is a mu plus small m plus capital M whole square we can add there. Okay. So that is the maximum height reached by this body there. And the center of mass will be the height of the center of mass. Height of center of mass is equals to this height of the tower plus this H maximum. Height of the tower plus H maximum we can write there. So it is equals to now H plus this one half by 2G into, so m u divided by small m plus capital M whole square. That is the answer. Option 3. Option 3. The height of center of mass is this height plus this is moved here and it is came down. The body is came down and it has not reached the ground. This capital M mass of the body is reached the maximum height there. In that case, the motion of the center of mass will be, it rises there, H plus the maximum height. Next term, last questions. Your numerical type question, it is there. 12th one. 12th one. A body of traveling 4 kg body traveling at 6 meter per second along x-axis collides with the stationary 2 kg mass at rest there. So if it is at rest, u is equal to 0, velocity will become 0 there, and first body has the mass 4 kg, no? So here we can write the m1 is equal to 4 kg and v1 is equals to 6 meter per second, and m2 is a 2 kg mass. M2 is 2 kg mass. This is a 2 kg mass and it is at rest there. This is at rest. Now velocity of the center of mass, they are asking velocity of the center of mass formula we know, m1 v1 plus m2 v2 divided by m1 plus m2, no? Same formula, m1 v1 plus m2 v2 divided by m1 plus m2. Substitute here, we will get the answer, that is 24 plus 0 divided by, this is 0, no? This will become 0, and here it is so mass is 6. So we will get here 4. 4 is the answer. So therefore, velocity of the center of mass VCM is equals to 4 meters. 4 meters. Now to the 13th one. 13th problem you see here. 13th one. There are different velocities are given there. So here this one. So this body 1 kg mass. This is a 1 kg mass of the body, and it is having the velocity, it is given like this, 1.5 meter per second, and this is a 37 degrees. One system, this is 37 degrees. Like this, another mass of the body is given there. It is moving 1.2 kg mass. This is a 1.2 kg mass. It is moving with the velocity 0.4 meter per second there. And next one, it is given there like this. It is moving like this. So with a velocity 1 meter per second, it is a 1 meter per second with the angle of 37 degrees. And mass of the body is here 1.5 kg. 1.5 kg. And next one is given a 0.5 kg mass is moving along the positive x-axis 3 meter per second, 3 meter per second, and this is how much here 0.5 kg. And another one is given here, this 1 kg mass of the body is moving like this. It is a 1 kg mass of the body and it is moving with 2 meter per second with an angle of 37 degrees. The angle of 37 degrees. Okay. So now here this velocity has to be velocity component of vector we should find out here. This will become 1.5 cos 37, and here we can write here minus I cap. So minus I cap we can write, and this will become 1.5 sin 37. This is a sin 37 j cap. Okay. So this is a 0.4 j cap we can write, and here this one along this direction. So this we can write like this, and this is negative minus 1 here cos 37 we can write, and this is a plus sin 37 degrees we can write there. So now it is moving along x-axis. So we can write here velocity is 3 I cap only. Here velocity we can write here 3 I cap because it is moving along positive x-axis. Okay, and here we can write this is a negative. So here 2 into sin 37 degrees, and this is 2 cos 37 degrees. See here we have all the vectors. So this is a j cap minus j cap we can write, and this is a I cap here we should write there. This is a minus cos 37 I cap plus 37 j cap we can write here. So velocities are given in the vector form. So now here we can write this formula, velocity vector of center of mass. We will get here m1 v1 bar plus m2 v2 bar plus, how many are there? 1, 2, 3, 4, 5. So plus m3 v3 bar plus 1 up to here m5 v5 bar, m5 v5 bar divided by, so m1 plus m2 plus m3 plus m4 plus m5. So substitute here, you will get the answer. So this you have to do. This velocity vector here, sum of these two we should write here, and sum of this one is v2 here 4 j cap, and v3 is nothing but we can write this one here. This is minus 4 I cap plus sin 37 j cap minus cos 37 I cap plus sin 37 j cap, and v4. So v4 is nothing but 3 I cap we can write here. Okay. So next v5. So this is a 1 kg into v5 value is here 2 cos 37 I cap minus 2 sin 37 j cap we can write there. So substitute there, we will get a vector. So from that vector, velocity vector, we should find out the magnitude, so that you will get the answer there. Okay. You can do is this one, and last one, 14th one. 14th one is given here like this. Two blocks are given here, two blocks A and B of mass S. One is given here 10 kg. Block A has 10 kg mass, and block B has a 20 kg mass. This is a 20 kg mass, and they are tied with the string, and here a force F is equal to, how much it is applied there? 30 newtons. 30 newtons is applied there. So they are asking the velocity of acceleration of the center of mass, they are asking there. This is a smooth surface. This surface is a smooth surface. Okay. So acceleration is the system acceleration of the body, we can write here capital M, F divided by m1 plus m2, no? m1 plus m2. So here this is a 30 newtons divided by 30. So how much you get there? Here 1. So therefore acceleration is 1 centimeter. So 1 meter. 1 meter, because that value is given in the meters, no? 1 meter. So this is the exercise problem we have completed there. In the next class, we are going to see their linear momentum and the collisions, types of collisions we are going to see. Okay. Thank you, children. Have a nice day.